Hello everyone. In this video, I want to give an introduction to this new project, which is a 3D roof project. And I'm going to talk about the rules and about some introduction and also the principle, the workflow, and how you can set up the software and what's the common tools and the case study for this project. And there will be multiple videos that introduce you about tools and different case that how we can complete in the 3D roof project. So for 3D roof project, this project is probably the most challenging project that we have ever done. It requires for your spatial imagination, your details orientation, and your thinking ability. So I want you guys to take the training very carefully and listen my words and watch my operation carefully as well. And once you have understood everything, including the rules, including the principle, and you can also follow the workflow, then you will succeed in this project, and I can ensure you that this project will highly reward for those people who can complete the result as expected. So first, let's take a look at the project introduction. 3D roof project needs to first take a building into 3D dimension, then draw a 3D model for the building's roof. And it requires building a correct relative spatial relationship between every roof structure part. And in the end, the result is expected to demonstrate the correct 3D roof structure for the building. As you can see in this picture, the building has been taken into 3D dimension and the building's roof has been drawn in the 3D model. And also, all the roof structure part has been built a correct relative spatial relationship. The height, the length, and the spatial location are all built correctly. And this is a correct 3D roof structure for this building. And this is the expected result in this project. Next, I'm going to talk about the principle and the workflow about how we can draw the expected result. So before we talk about the principle, we need to understand the definition of roof structure first. So the roof structure is defined by ridge and hip, which is essential to understand first. So as you can see, ridge. Let's talk about the ridge first. Ridge is a line that determines the height and the slope of each roof panel. The ridge is defined by three elements, three factors. First is the correct location of the ridge. And second is the correct length of ridge. Okay, after we have the location and length of the ridge, then we need to define the correct height of the ridge. Okay, so as you can see, this is the roof, the building footprint, and the ridge is this tall above the footprint, and it's in the middle of the footprint. So, and this is the length of it, maybe half of the footprint. So this is three elements that determine the ridge. And as you can see in the picture, after ridge has been defined, the slope of each roof panel is connected to the ridge. So ridge is the most essential definition and the most essential step to draw an expected 3D roof structure result. Second definition of the roof structure is a hip. Hip is a line that connects between the ridge and the building footprint. As you can see, there are two ends of the ridge, and this is a footprint, right? So the hip will connect each footprint edge point to the ridge. So there are two heaps in the front and two heaps at the end of this, at the back of this building. Okay, so after we understand the ridge and heap, the expected result of the roof structure is actually the correct drawing of the footprint, including every details, and the ridge and the heap, which we require for the location, length, and height. So after we have understood the definition of roof structure, including the heap, the ridge, and the footprint, then we are almost halfway to success in the 3D roof project. So next, it's about the workflow, about how to complete, how to follow in the 3D roof project. It's very essential because following the correct workflow is the key to success in this 3D roof project, and no matter how complicated the roof is. Okay, so the workflow, as I have said, is the same thing requires for this project. It requires for details-oriented, spatial imagination, and thinking ability. So first is we need to draw the footprint. We need to capture all details for the footprint. And second, we need to draw the broaderation if necessary. Okay, so including for parts of different height in the residential building. So if the part of the residential building is lower than the main structure, then it requires us to draw the broaderation in the for the 3D roof structure. Second step is to draw the top and or the highest ridge. Okay, so we need to find out the correct location, the correct length, and the correct height for this ridge. Number three is we need to divide the footprint for the top and highest ridge. For example, like this one, we need, if this is the top and highest roof ridge, and how we can divide the footprint is we can divide it like this. Okay, we can divide, like draw a line here, and this is the footprint part that is for the top and highest ridge. Number four is we need to connect the top and highest ridge to the corresponding footprint part. So in this example, this is for example, if this is top and highest roof ridge, then we can connect this to the footprint part like this, and then we need to draw a line to here as well. We need to draw an extension line all the way to here, and this is the corresponding part for the top ridge, and then we can connect it to this part as well. Then we draw the ridge for the following neighbor's roof structure, as we have seen here, right? This is the following neighbor roof structure, and this is the following neighbor's roof ridge, right? So we draw this, and then we just connect the neighbor ridge, this neighbor ridge, to the corresponding footprint part. As you can see, we can connect here to here, right? This is a part of the neighbor's roof structure, and this panel we connect here to here. This is the second one. And lastly is the extension. We imagine this extension to here, then we need to connect this to there. Okay, so this is how we connect the neighbor's ridge and the corresponding footprint part. Lastly, repeat the step 5 to 6 neighbor by neighbor. So even this is two roof structure combined together, if there's more roof structure combined, then we just need to repeat step 5 to 6 neighbor by neighbor to complete this 3D roof structure. So after we have understood the workflow, which I will also talk about the workflow in the actual project video. Next, let's talk about how we can set up the software. First step is to make a copy of the Ginger software folder, like what I did here. The first one is for the regular project. The second one is a copy, and I name it as roof. Then you can download this link and unzip this all the files here to the copy of the Ginger software folder. Then you can log in as what you usually do for the regular project. And if the software gives this message, you can click OK to continue. Okay, just ignore this. Lastly, don't maximize the software window, but you can enlarge it to a comfortable scale. So that's everything for the software setup. It's pretty easy. Next, let's take a look at the tools introduction. And this tool section, I will also have a video for it. Okay, so don't worry about it. So let's just take a look of very quickly. Besides drawing, repair, and matching tool that we did in the regular building repair or the 3D matching project, there are a few new tools in the 3D roof project needs to be introduced. The first one is the assist line. So the shortcut key is number 9. So assist line is we can, in the previous project that we cannot draw a line, right? We have to draw a polygon, we have to draw a building, we have to draw a box. But with this tool, we can draw a line, and this line can help us to find out the ridge and can also help us to divide the footprint for multiple roof structure combined building. And number 2, there is a tool that will delete all assist line, and will if there are too many assist line being drawn, then you can delete all of them to give you a clear image. And number 3 is a flip view. What is flip view? Is that in the roof structure, in the 3D roof project, the left image and the right image can be flipped, can be switched. So you can draw on every image, and every image can also be treated as right image to adjust the height. Number 4 is to enter 3D mode. So the building can be entered in the 3D mode, and you can examine every direction of the building. And also you can reset to exit the 3D mode. And also you can reset to the main views, which will, if you move the building too far, then just click this view, just click this tool, you will zoom in back to the main views. And number 7 is a face split. So what is a face split? It's pretty complicated, and I will talk about it in the video. And lastly, is a polygon adjustment mode, and this is also kind of complicated, and I will also talk about in the video. So for the case study, there will be a few cases, including for the gable building, for the multiple gables building, broad relation building, Dutch building, and complicated building. And you can watch the video for each one of them in the training folder. Okay, so that's everything for the 3D roof project rules and introduction. Then let's watch for the case study video and tool introduction video to master and success in this special project.